Hey everyone, welcome to another video. So this is the second video of our LangGraph crash course series. So in the previous video, we discussed about why LangGraph is important and how is it different from Langchain agents. If you have not watched that video, click on the icon above and get that basic understanding first. Okay, what is LangGraph and why do we need LangGraph? So in today's video, we are going to basically create a simple chatbot with a managed state using LangGraph, and that will give us the basic idea about the building blocks of the LangGraph. So this is our step number one. So let's start with that. So what we are going to do today is basically, if I explain you, so we'll have a node as LangGraph is DAG, right? Directory acyclic graph. You can define multiple workflows. So we'll have a node. Let's say this is our chatbot. Let me just reduce the size. Then to this LangGraph, we'll have our LLM, all right, and a state. Cool. So this will be our state, and we'll have our LLM. So in our chatbot node, these two things will be integrated. So now let's just start coding. Let's start designing, and once both of them are integrated with the chatbot node, then we can pass in the user input from the user and it will give us the output. So first let's just design. It's not a complete graph, but this is just, as I told, this is just the stepping stone of learning LangGraph and seeing LangGraph components in action. Okay. So first here I have just imported my OpenAPI key because we will be using our OpenAPI models for LLM, right? So that's why I have my OpenAPI key. I'm just inserting that. Then what you have to do, you have to install two packages. Okay. First one is you have to install the LangGraph package because you will be using LangGraph, of course. And next you have to install the Langchain also because LangGraph is built on top of Langchain and we will be requiring some of the packages and modules from LangGraph also, Langchain also. So once you are done with the installation, I have already done the installation. So first what we'll do, we'll first import some packages. Okay. So what we'll do from Langchain dot, first we'll just import the OpenAI model because this is what we are going to use. Chat models, I guess. So this is what we are going to use as our LLM. All right. Then from LangGraph dot graph we'll import state graph. So using this state graph constructor, we'll be creating our graph. We'll see that in a while. And then we'll import some other tools also from typing. Let's import typedit. So this will be used to define our state, application state. I mean, the state will be defining that we saw, right? So now once we are done with the importing, now we'll create our state. So now what we'll do, first we'll define our LLM, then we'll define our state, then combine that together to form the LangGraph node. All right. Now let me just define my LLM. Let's say the LLM that I'll be using is chat OpenAI, and in model we'll use the GPT-4 Omni model I'll be using. And let's just pass it the API key. Cool. Now let's just run this and initialize our chat OpenAI. What is wrong? Achha, sorry. Here I'm, instead of equal to, I gave a minus symbol. Sorry for that. Yeah. Now our LLM layer is ready. So we are done. We are ready with this LLM part. Now we'll just define the state. So for that we'll be using this typedit. Okay. Now what we'll do, we'll mention a state. So why state is important? By default, LLMs does not have any memory. Okay. I mean, let's say you pass one message to the LLM model, and let's say pass that, hey, I'm Preetham. It will immediately give you a response that, hi Preetham, how can I help you? The next time when you ask what is my name, it won't be able to answer because the LLM models, right? The LLM models that they have, they do not come with inbuilt memories. They just know how to process an incoming input query and generate the best possible output. Okay, just predict the best possible output for the given input query without preserving memory. But with the help of state, we will be able to preserve those memory also, that we will see in a while. But for that, let's just define the state. and here we will have a messages list which will be maintaining the hold the message history. Okay, that will be interacting with the LLM model, right? So it will hold a message history for us. Now let me just run this. Now once we are done with this, now we'll define our what? Now we'll define our chatbot node. Okay, and for that, let's just define the chatbot node function. And if you see here, this is where we are binding the node, this graph node. So this is our chat node. We are binding the state with the chat node. This is how we are doing it. And what we are telling is it will return something which will be returned to the chat state. All right. Now let's just define the function. So what we will do, we'll first fetch the existing messages, like whatever the messages are there in the history. We'll first fetch that, and you can access that using messages key like this. Okay, because this is the messages key. This is being passed, one instance of the state is being passed as the input to this chat node, right? And you can access the messages key like this. We are done. Now what we'll do, we'll generate a response by invoking the LLM model. So we have our LLM model. Then what we'll do, we'll pass the messages list, message history, and ask it to generate a response for that. Now once the message is generated, the response is generated. Once we get the response from LLM generated some response. Now that response, we will be putting it inside the state, because we are maintaining a chat history, right? So now what we will do, in the messages list, we'll append the message, and role will be assistant. If you don't know about these things, like what is this role, what is this content I am giving, why am I giving all these things, if you don't know this, I'll suggest you to watch the crash course on Langchain first. You can click on the icon to explore the Langchain crash course. There I have defined all these OpenAI format. So this is the OpenAI messaging format that we can pass into different LLM models. Okay, so this is the standard format that we follow. So I'll suggest you to watch that first to have a deeper understanding about this thing. So basically what we are doing here is this response is generated by the assistant or the LLM. So the roles can be three types: user, system, or assistant. User is what we type, that we are going to write in a while. Assistant is what I got the response from the LLM. So that's how we define the hierarchy, like assistant message, user message, then assistant message, user message, like this, so on and so forth. Then we have added that. Then finally what we will do, return the state. So once the message list have been updated, we are now returning this, which will be returned to our state, right? The new message will be added to the state, and that's how we are maintaining a chat history here. Let me just run this now. So with this, we defined our chat node. Now it's time to build this graph. You're done with this. Now you have to define a proper flow, right? Like where the user input will be coming, how the output will be generated. Now this is where we'll be building our graph. So let's say we'll create the graph, and here what we'll do, we'll use the state graph class. We'll create an instance of that using our chat state. Okay, so this is the chat state that we have given, and I'm creating a state graph here. Right, now what we'll do, we'll add the chat node in the graph. Now how do you do? You can do a graph dot add node and name the chat node, you can mention the name of the node. You can give something like this, and then you define the function. Okay, so this is the chatbot node I am adding. This is my chat node, and this is how I am adding the chat node. Okay, now what we'll do, we'll have to define one entry point. See, it's not just enough to add a node in the graph. You have to define which one is the entry point. Let's say you have multiple nodes like this in the graph, right? Then you have to define from to which node the user query will be passed. So you have to define the entry point. In our case, as you have a single node, this will be our entry point only. So what we'll do, we'll just graph dot entry point, we'll mention the name of the node. This is the name of the node that we have given. This will be our entry point. Now once we are done with that, we'll just compile the graph. Once all the configuration, all the structure have been given, we'll just compile the graph. Now our graph will be ready. Let me just run this. And if you want to see it visually, so what we can do, there is a library called IPython. We can import that. From that we'll import image and display method, and then we'll try to visualize this graph. Okay, so we'll call this display function where we'll be generating the graph. So this chatbot comes with a get graph method. Okay, you can call that and ask to draw a, you can then call the mermaid png method on top of that. Did I miss something? Display image. For now let's just pass. Yeah, now you can see, we see how the graph is created. Okay, we have a starting endpoint, and the start is defined as the chatbot. So this is our entry point. As you have a single node, that's how our graph looks like. Now once we are done with this, this is now what we'll do, we'll now start interacting with this chatbot. Okay, so initially our state will be empty, right? Let's say we define an empty state. So we'll have empty state to start with. Then we'll write infinite for loop where we'll be taking the user input first. Using the input function, we'll ask the user to give the input. Once he gives the input, we'll just do a basic check. We need to break somewhere, right? We need to get out of the loop somewhere. So let's just use this, like, let's say user can give something like this, okay, and if input are some of this text, you can define any message as you want. What you will do, you can just print something ki chat session closed and just break from the infinite loop, right? Now we are done. Now once we are done with that, what we will do, so what we will do, we'll then append the user message, okay, in the OpenAI format. We'll then mention role as user, correct? And so this is the OpenAI format that I am writing. Okay, content, and content will be user input. Okay, now basically in the empty state we have added the first message which was given by the user. Now using this state, what we will do, we'll get the new state, then invoke our chatbot. So this chatbot node that we have write here, the chatbot graph, we have LLM graph. We are going to invoke that with our existing state. First we'll pass the existing state, and finally when you invoke the chatbot node, it returns a new state, right? Updated state it gives. So that's what we are keeping here. And from the updated state, the latest message will be the message from the bot. So from the messages list, we can fetch the last element, last object in the messages list, and we can print its content, because the output will also be generated in the OpenAI format. There will the output, how the output is, as you saw here, we are having a role here and content here. So the content of this object we are printing, right? We are done with our chatbot implementation. Let's try running this first. Okay, let me just run this. Yeah, now if you see user input session is open, I will just type this hi. Let's wait for the response. Does not have any attribute. Okay, maybe I have to access it like this. Let's run once again. Let's type hi. Yeah. Now we'll see the power of states, right? Let's say I give it like hi, I am Pritham. Now what happened? What is the error? Assistant. They use one of. Acha, I've done a spelling mistake, I think. So this will be S is missing. So this will be assistant. Let me just run everything again. Okay. Let's run hi. Hi, I'm Pritham. Yeah, it took some time, but finally I am 26 years old. Okay, now I'll ask him, what is my name and age? Because it is maintaining this chat history, we are updating the state and feeding it back to the node, right? I mean, the node is always linked with the updated chat history, right? Because every time we're updating the state also, if you can see, and we are then updating the chat history in the state. So our chat node is aware of the past conversation history, and that's how it's able to answer my question. Your name is Pritham and you are 26 years old. How can I assist you further? Now let me just end the session. If I print by, we are breaking out of the loop and the chat session is closed. So that's how you build a quick chatbot using LangGraph, and I hope you understood the basic building blocks of a LangGraph uh, agent, which are nodes, then how to manage the state, how to update the state, how to pass state to different steps of the process, how to define node, how to create a graph, and finally how to interact with it. So if you understood the basics, and if you have any questions about whatever we discussed in this video, put them in the comment section. So in the next video, we'll go one step further. We'll try adding multiple nodes in the graph, and then we'll create a defined workflow and see how it is working. Okay, how to create multiple nodes, how to create edges between them, and how to pass information from one node to another, and we'll prepare a more powerful agent, LLM agent using LangGraph in our next video. So that's all for today's video. So if you like this video, let's target for 40 likes and subscribe to my channel. We are targeting to reach 2500 subscribers by the end of this month. So keep supporting. So thank you for watching this video and I will see you in the next one. Thank you.